50%.
Okay, you jawab dekat chat saya tengok. 50%, 50%, 50%, okay. Okay. So actually without an example, you just like listen without really understanding it. Is it? Is that the thing, the case? Yeah. All right. So that's why I would like to have the class today live and meeting you guys today so that I can show you how actually you should deal with a question that you get on this topic. Okay. So let's see. I will share the slides first. So what? Okay. Where is my presentation today? Okay, can you see the slides? Yes?
Yes, Doctor.
Yes, Doctor.
Okay, so let's see. I have covered all this. So whenever you don't understand, you can always go back to the recording and see which part of it that you really don't understand. Okay, so let's see the question. 10.51. So you all have received or have seen in e-learning that I have uploaded the what do you call it, the book, right? So you should be able to get a copy of Jean Copley's there in sorry, saya tengah cakap dengan Dr. Zaki. Sekejap saya cari buku Jean Copley's ni so that I can copy the question. Tu Ikmal, Dr. Zaki panggil Ikmal.
Fiz.
Dia, abang dah habis kelas ke?
Baru habis kapok.
Dr. Zaki also has class today until 4. So, but he finished early maybe. Kejap. Ya, saya nak cari buku tu so that... okay. Because from the first question I gave you all in the first... for the first topic, I see that some of you do not have the book, right? So that's why I uploaded that. So which page is that question? 10 point. Let's see which page. Which page is it? Do you remember? I want to see the question.
650.
650. Can you see my screen? What do you see on your screen? You see the slides, right?
Yes.
Okay. This is example. Example lah. Example 10.51. Bukan 650. Oh, sorry. Sekejap. 650. Okay. Bear with me ya. Kelas online ni macam ni lah. Sabar. Okay, so let's see where the question is. 10.51. Tak ada pun. You cakap page berapa? 650? Tak ada pun dekat 650. Or you are using the new book or what? Aina Syahira. Page mana?
650.
Example 10.1.
Yes, buku baru, Doktor.
Oh, yang who are using the book that I uploaded? Ya, I cari sendiri ni manually ni. 10.51, okay. Okay, dah dekat. Okay, alright. So here's the question. Because I want to take the question actually and put it there in the slide so that it's easy to discuss with you guys. I just finished FYP2 briefing actually, so kelam kabut sikit today. So kita tengok sini lah, kita insert slide. New slides. Okay, so this is the question. Okay, so this is the question that you should be doing for example 10.51. You all have your graph paper with you, right?
Yes.
Yes. So actually, okay, what you have here is actually to design a cooling tower using film coefficient. Because there are actually two methods that I showed you in the recording, which is one using film mass transfer coefficient, and the other is using overall mass transfer coefficient. So in this question, you have a packed counter current water cooling tower using a gas flow rate of G of that and a water flow rate a water flow rate of L equals to 1.356 as well to cool the water from TL2. So the incoming water is actually 43.3 and what's going out, or you want to produce the cooled water to 29.4 degrees Celsius, right? So the entering air is at 29.4. This is the dry bulb temperature and you have a wet bulb temperature of 23.9. Who remember what is a wet bulb temperature? Siapa yang kena? Saya nak tengok siapa partisipan hari ni and I want to ask. Sekejap. Siapa? Shuhaib. Who's Ahmad Shuhaib? Are you here? Ahmad Shuhaib? Turn on your camera, Shuhaib. Dah. Turn on your mic. Tak dengar, Shuhaib? There's something wrong with your mic kot. Cuba cakap. Tak dengar. Testing, okay. So, do you know what temperature is?
Temperature paling rendah.
Temperature paling rendah?
Waktu apa? Waktu
apa?
itu disejukkan dengan water.
How do you measure it? Wet bulb temperature?
Wet bulb temperature
Guna?
yang graf ni lah.
You guna apa? Nak measure wet bulb. Sekejap I want to make sure. Is there any international student? Ada.
Yes, ma'am.
Ada international. Apa? Macam mana?
Kalau kat graf ni dia yang gradient lah. Dia punya garis tu.
Bukan kat graf. Saya tak nak yang dekat graf. Saya nak how do you measure wet bulb temperature? How do you measure?
Measure. Dah.
Kalau nak pas, cakap pas. Nanti saya tanya orang lain supaya boleh tolong. Pas dulu. Okay, Romaldo, who's Romaldo? Turn on your camera, turn on your mic. I want to see you, I want to hear you. Tak ada lagi cakap. Romaldo ni pick A dia.
Hi, doctor.
Romaldo ni. Okay, ternampak. Gelap sangat tu. Okay. So Romaldo, what is wet bulb temperature and how do you measure it?
The wet bulb temperature is the lowest temperature where the air can be cooled by the evaporation of water.
You're reading from somewhere.
Yeah. I Googled before it.
Okay. So how do you measure it?
The one I'm not sure.
I have said it. I have recovered that in the recording. I mentioned it. Have you seen the recording, or you did not see the recording
Already last
already,
night.
but you didn't get it?
Yeah.
Okay, wet bulb temperature is actually the lowest temperature you can achieve in the humidity that you have in your air at that particular condition. And it is measured using a thermometer with wet cloth or wet wick around the bulb. Okay, so that dia punya humidity is actually 100%. Sebab dia basah kan. Jadi bila dia ada bulb and then you dekat bulb tu you cover dengan wet cloth, that is like simulating a 100% humidity condition. Okay, so that's the lowest temperature that you can get from the dry air and the humidity that you have at that particular condition. Okay, so I hope you will remember that. Maybe I want to ask in the test ke, dalam quiz ke, okay? So you have to remember that. All right, so the wet bulb temperature in this question is 23.9 and the mass transfer coefficient KGA is estimated to be 1.207 times 10 to the power of -7 in that unit. And you have HLA over KGA MVP as 4.187 times 10 to the power of 4, that unit. Okay, and the question is to calculate the height of the back tower Z. And the tower is operating at a pressure of 1.013 times 10 to the power of 5. So how do you actually have to do this question? First, I want you to take a piece of paper, all right? Take a piece of paper and draw this sort of a diagram, something like this. And please use the information in the slides just now. Okay, use the information in the slide, in the question, not in the slide, in this question to draw the diagram. So you have the water stream coming down as L2. You have the gas stream going up as G1, okay? And draw. So that you can understand on how it actually is. Okay, so every time you get a question like this, you should start with drawing the schematic diagram or the block diagram of what goes in, what's coming out of the unit operation. Okay, so all right, once you got that, you just write down all the conditions you have. Okay, write down all the conditions you have, what sort of flow rate you have for the gas, what sort of flow rate you have for the liquid, which is the water in this case, and what is the temperature you start with, and what is the targeted temperature that you want to achieve for your water stream. Okay, so you have to remember in this topic, what your objective is to cool down or to reduce the temperature of the water stream coming into your cooling tower. Okay, so these are all the conditions given to you. You can see my cursor, right? Boleh nampak cursor? Yes?
Boleh.
Okay.
Yes, Doctor.
So the first step, if you still remember my the recording I posted in the e-learning, the first step is for you to determine the humidity from the charts. So you still remember what's the figure for the humidity in your transport processes? What figure? Which figure? How do you find your humidity now? Right. So if you look at this condition, the dry air, so I want you to go to the humidity chart you have in your transport processes book, in the Jean Copley's book. Turn the page to that humidity chart. Dah jumpa humidity chartnya? Dah?
Ya, jumpa.
Okay, now I want you to use that particular humidity chart because in our question in the exam and in the test, we usually use that particular humidity chart. We will use the same chart. Okay, not the one like in this slide, but we will be using something or the same humidity chart as in the transport processes bit. So what I want you to do next is for you to go from the bulb temperature, which is 23.9, okay? Draw a vertical line to meet the 100% humidity or the saturation line. Are you done? Kalau dah cakap yes, saya malah nak buka chat you all. Cakap yes ramai-ramai. Kalau dah siap.
Yes.
Okay. Now you go to you have to take your ruler and you have to be careful so that your line is really parallel to the wet bulb lines, okay? Because it depends on how accurate you draw your lines, whether you get an accurate value for your humidity, okay? So I really hope you can draw a parallel line to the wet bulbs line, okay? Then you draw the dry air temperature or the dry temperature line vertically as well. And now you want to go to the right to read off the humidity value for this condition. So what do you get? Ain. What do you get, Ain? Ain Aziz. Who is Ain Aziz?
Me.
What do you get?
0.016.
0.016. Chong Kai Lun. What do you get?
0.016, I think.
0.016. Siapa lagi? Akid. Who is Akid? Ada tak Akid? Which one is Akid? Tak ada. Or he has no camera or no mic. Akid, are you here? Or sudah pergi goreng ikan, main bola? Ke apa?
Doktor, saya dapat 0.018.
Siapa tu? Akid ke?
Iqbal.
Iqbal. Oh, Iqbal dapat 0.018. Alright. Who's El Kindi? Can you turn on your mic? I would like to see who you are.
Yes, doctor.
Can I see you? Where's your camera?
Hello, doctor.
You're from
Indonesia.
Indonesia. Saya ingat orang Arab ke apa tadi namanya El Kindi gitu.
Yes.
Oh, are you in Indonesia or now in UTM, in JB, in Malaysia?
I'm in Indonesia right now, Jakarta.
You're in Indonesia.
Yeah.
In Jakarta. Alright. So, Dr. Zaki ni kat depan saya, dia kacau saya. Dia tanya, El Kindi ni dari Jakarta Barat ke, Tengah ke, Tepi ke? Alright. Jangan layan dia, tak apa. You're in Jakarta, right? Alright. So, what do you get for your humidity?
0.016.
0.016. So let's see what is actually the right number. So this is what's given by the book. Okay, you should be able to get 0.0165 for the humidity for this condition. Okay, so we will see. You use your number, the number that you get in the subsequent calculation. Please use your number, okay? So that we can see whether you will be doing some errors or how will the decimal place really affect the final answer, okay? So from that humidity, okay, you have to put into this equation for you to calculate the enthalpy. The enthalpy of what? What? The enthalpy of what? You rasa-rasa enthalpy of what is Y1? Nila Satya. Who's Nila Satya? Nila. Mana Nila?
Hello.
Mana? Turn on camera. Okay, ni lah. HY1
yeah.
is the enthalpy of what?
HY1. Enthalpy at the bottom of the
Enthalpy of what?
of enthalpy of the bottom of the tower.
Okay, enthalpy of the air coming into the tower. Okay? So the way for you to calculate HY1 is using this equation and using the humidity that you get from the chart just now. Whatever the number that you get for your humidity, please use it in this equation and we will see how far is your number compared to the number in the book. Okay, because you are going to practice on how to solve this kind of question when you see them in the exam and in the test. Okay, so put in your actual number into this equation. So berapa dapat semua? TG1 is the temperature of, what is TG1? Luqman Hakim, what is TG1? Where's Luqman Hakim? Siapa? Luqman Hakim? Oh, Munabir. Munabir? Oh, Munabir International.
Yes, ma'am.
I hope you can understand your colleague here. they tend to speak bahasa, all right? So mana tadi? First Luqman Hakim and then Munabir. Luqman, what do you get for your what is TG1?
Luqman, his mic got problem.
Mic dia problem tak tu?
Yeah,
Oh,
and
saya
he
tak
said
tengok
the
chat
TG1
tadi.
is 29.4. He didn't check.
TG1 is 29.4, which is the temperature of the
Guess.
gas, the dry temperature. The dry temperature is actually the actual temperature of the air or the gas coming at the bottom of your tower. Okay, so Munabir, what is the value you get for HY1? What's the number?
H11?
Yep. Are you done with the calculation from the equation?
No, not yet.
Not yet. Naufal, how about Naufal?
Yeah, yes, doctor.
You get your HY1 already?
Not yet, doctor.
Not yet. Lamanya. Bukan you all terror ke kira-kira ni semua?
717.
Aiman, tell the answer.
Apa Aiman?
7.17 times 10 power of 3.
7.17 times 10 to the power of 3. Aiman, cuba adjust you punya kamera tu, nak tengok muka you macam mana sebenarnya? Which one is you? You yang ketua kelas ni. Tak nampak lah, gelap. Okay. Memang tak boleh jam. Tak nampak. Okay. So
7.17 times 10 power of 3.
what sort of humidity you use? Your H?
0.0165.
Oh, you got 0.0165 originally in
Yeah,
your chart?
from this one.
Okay, because I'm asking you to use the humidity that you get from your own chart, from your own calculation or your own determination from the chart, so that we can really do this as an actual exercise or actual test or exam. Okay, so if you get your H to be 0.016, just use 0.016 in the calculation. And do this properly in a piece of neat paper. Yeah, do this neatly, because at the end of the class, I will upload a link in e-learning for you guys to scan and give me the example that you have done today in the class. Okay, so bukan main-main je. You have to do it neatly, and then I want to see that. You have to upload. Okay. So if you use 0.0165, you should get 7.17 times 10 to the power of 3. Ikmal, tadi you pakai 0.016. So what is the number you get from 0.016?
Saya pakai 0.018.
Oh, 0.018. So
Saya dapat 75.6 times 10 to the power of 3 joule per kg.
75.6? That's
Sebab
wrong.
sebab nak
Oh,
plot
times 10
nanti
to the power?
3.
Oh, tak betul tu. That's wrong. Mesti salah calculation somewhere. It should be near the number. Siapa pakai 0.016? Aina tadi eh?
Saya.
Saya 0.017.
Dapat berapa?
72.986 times 10 to the power of 3.
72, that's so far from...
Ah,
I don't think it should be that far
sebab
from...
dalam buku tu dia punya decimal place dia salah, doktor. Dia
Oh
sepatutnya
yes, ni betul. Saat buku Jin Publish tu, so you shouldn't get 7.17, you should get 71.7, right?
Yes. I got
If
70,
you're
Doctor.
Yes.
okay, if you're using 0.065, you should get 71.7. Betul?
Betul.
Right? Okay. So, jap ya. So tadi Aiman, you salah lah, dapat 7.17.
Saya tak perasan.
Okay. So it should be 71.7. Thank you for reminding me. Every year this happens. Okay, saya selalu lupa nak correct my slides. All right, so enough with this. So you are now at step number 2, which is to calculate HY1. Now we'll go to the next step, which is to...
Doktor,
yes.
so I keep using my value tadi,
Yes,
75.6.
you can keep using your value because this is actually to replicate what you're going to face in the exam and in the test. So kalau dalam test nanti you're using the same humidity chart that you see in the book. So that's the number that you get from your humidity chart, then use it. Okay. So when you use 0.18, what's the number? 70? 75?
75.6.
Okay, so just keep using that. We see how far will be your answer from the answer in the book. Okay, now we are at step 3. Okay, step 3 is for you to calculate HY2. If the HY1 is at the entrance point of the gas, now it's at the exit point of the gas. So you are going to calculate HY2 from the value of HY1 and also from the value of TL2, TL1. What is the value for TL2? Nazirul Afiq, who is it? TL2 you berapa? TL1 you berapa?
TL1 is 29.4, but TL2 is 43.3.
Okay, so TL2 is 40.3, TL1 is 29.4. Okay, what is your G?
G is 1.356.
Okay, your L?
1.356.
Okay, and use the HY1 that you get from step 2 and for you to calculate your HY2. Now do the calculation with by using the CL or the heat capacity for the liquid at 4.187 times 10 to the power of 3. And remember, in the exam or test, you have to be sensitive with the unit. Okay, so in this case, in this question, all the units are homogeneous or using the same units. But in the exam, please pay attention on the units that we gave you on all the values. Yeah. All right, so if you calculate this, what do you get? Oh, what should you get? So you should get HY2 as 1.29.9 times 10 to the power of 3 joule per kilogram of dry air. And all of you manage to get the a reasonable number or a number close enough to this? For those of you who are not using 0.0165, siapa Zafri? Who's Zafri? Zafri. Yes. What's the number you get for H12? Mana is Zafri? Can't see you. Okay.
128.65 times
128.65. What's the value for humidity that you use?
0.016.
Okay. All right. So you get 128.65. Okay. All right. So your number should be quite near to this number. If you use 0.0165, this is the sort of number you're looking for. Okay. So next step. Okay. Oh, kenapa tak boleh? Okay, let's see. The next step is for you to plot the equilibrium line. Now go get your graph paper, all right? And we will use the table 10.51 in your Gincopolis. Table 10.51. Okay. Go to table 10.51. Okay, kejap. I'll mana table 10.51. I'll screenshot that. And it's quite tricky. Actually, for your exam, you will be using or you will be having your exam open book, okay, as an open book exam. Kejap. So insert this. Alright, so this is what you're supposed to be referring to. Okay, so siapa tahu how to plot the equilibrium line? The equilibrium line should be not this one. Pula. Okay, what against what? The y-axis should be your enthalpy. Your x-axis should be your liquid temperature. Okay, so if you look at this, okay, I want you to use your own graph. Do not use the graph or the plot given in the example, all right? Use your own. So what you want to plot is the temperature, okay, and the corresponding enthalpy to that temperature. If you couldn't find, so let's say if you look at the left set of data here, okay, sini, left set of data, you have TL from 15.6 to 35. So what sort of range of the temperature that you want to be doing the plot at? What is the minimum value for your enthalpy and the maximum value for your enthalpy? Siapa saya nak tanya ni? Nakiyuddin. What is the minimum value for your HY1? Sorry, for HY. What's your minimum value? Mana Nakiyuddin? Are you here?
Yes.
So what's the minimum value for your enthalpies?
Coffee is 43.68.
And not for this equilibrium line. For your, what do you call it? The decalculated HY1 and HY2. What's your HY1? What's your
Okay.
HY2?
HY1 is 7.15 times 10 power 4.
7.15.
Times
Then
10 power 4.
10 to the power 4. Then
And HY2.
7.15 ke 71? What you should get it should be 71, not
Daughter to the power of 4.
7.1.
He said to the power
Oh,
of 4.
you okay? You to the power of 4. Okay.
Yeah.
All right. So you should use the same exponential. If you use to the power of 3, then all should be to the power of 3.
Okay. So
Okay.
71.5. Okay.
Okay. Your HY2?
HY2 is 129.7 times 10 to the power
129. Okay. So if you see the table here, okay, what's the temperature? TL2 is what's your TL2? 40 berapa tadi? TL2?
43.3.
43.3? 42.3? 43.3. And then your TL1 is 29 point, berapa tadi? 29.4. So if you see the sort of data that you have, your TL2 is 40 something, your TL1 is 29 something, and your HY1 is 71 something, right? Times 10 to the power of 3. And your HY2 is berapa tadi? 128.65, which is okay. So looking at that data, do you think you should plot all the points or you should only plot the data on the left? Sini. So this is your equilibrium line. If you plot all of these, okay, from point number 1 to point number 10 here, you will not be using all these points actually. And your graph will be small because you want to plot all these points which are not going to be used, okay? So when you want to plot your line, you want to see what sort of range you're working with, and then only you decide on where to start on the x-axis and also where to start on the y-axis. So what you want to plot is actually the 2 points at the point at the bottom is actually T1 versus, sorry, this point is actually, sini. Okay, saya conteng lah so that quite easy for you guys to see. Okay, so let me scribble. Okay, this is actually the point where you plot TL1 to apa? Dekat tepi kiri tu is actually your HY berapa?
HY1.
HY1, right? So this is HY1. This is TL2 with HY2. So you have to be careful as well because if you see this plot, right? So you have TL2 here, but you don't only consider the maximum value of HY2, which is 128, right? Because what you should be able to cover is you should go up vertically, okay? You should be covering that point in your graph, not only up to this, okay? So you have to cover up to that point. So if it's up to that point, what sort of a HY is that under 200? So let's see if you have under 200. Mana tadi your 10.51 tadi? Ni. Under 200 is actually here. So if you don't want to like give it don't want it to mess with your head, you want to plot all of that, you can do that as well in your exam. So in this case, if you see here, where the temperature is concerned, or no, not the temperature, the enthalpy is concerned, you want to be able to cover up to 200. But you don't know yet because you don't know vertically how far it should go, right? So if you want to plot all the points, that's okay as well. Okay, so when you plot all the points, this is how it should look like. Okay, now you should have this equilibrium line plot. I want that line. Are you done with the equilibrium line? The yellow line. So now we just plot all the lines. That's okay. Just plot all the points from the from table 10.51. Just plot all the points. You done? I think in my class now there's many boys compared to girls. Girls saya ada siapa saja? Satu, Aina, Dora, Edith, Jane, Ivoni. Lian Wen Wai ni boy ke girl?
Boy, doktor.
Boy. KW ni siapa? Who's KW?
It's me, doctor.
What's your
Kelvin.
name?
My name is Kelvin. Yeah.
Nanti letak sini Kelvin so that I know you're Kelvin, okay?
Okay, next time. Okay.
Then Shalini. Siang is a boy or a girl?
Boy.
Siang is a boy. So that's about it. Sikit je girls kan? Around 4 to 5 girls. Yang lain semua boys. Alright, so are you done with your equilibrium line? Tengok dia jawab cakap. Okay. Okay lah, saya buka chat lah. Kadang-kadang you all tak nak buka mic. Dia tanya dekat chat saja. So let me see. Edith tanya ni for 2 decimal place for what? Edith.
Yang
Which
value of HY1 and HY2 that calculated.
Okay. But you don't round up too early in your calculation because maybe there'll be like accumulated errors from the decimal places. Okay, so you try as much as possible to keep the number as it is. Okay, don't round up first. Right, so are you done with the equilibrium line? Yes, cakap yes.
Not yet.
Not yet.
Not yet.
Kena cepat ya, because in your
Not yet.
exam kadang-kadang you have to plot like sometimes 3 to 4 graphs in one session of exam or test. So you have to be really good at plotting the lines, the graph. In this course, you really have to plot a lot of graphs. So you have to be really good at it. So how long are you going to take? Do you have class at 4? Other class at 4? Tak ada kan?
No.
So we might finish a little later than 4 because I would like to finish this example with you so that you understand what I was talking about in the recording I posted in the e-learning. So, dah ke belum?
Saya dah.
Dah. Right, so can we move to the participants there. Chat there. Okay. So when you already have your equilibrium line there, you should proceed with the operating line. Okay. So operating line in this figure is this green. I mark with green lines. So point number 1 is TL1 HY1. TL1 HY1. Okay. This one is TL2. Tak boleh tulis pula kat situ. TL2 and HY2. Okay, over there. So 2 points, just draw a straight line connecting those 2 points. Easy, right? So now, in doing all these, you should always put in your focus what is it actually that you want to achieve by all this. Okay, so you have to remember the root of the question, or the aim of the question is to calculate the height. So pergi tengok, if you're confused, just go to the equation that will bring you to Z. What is the equation for Z? Mana equation for Z? So if you are confused, go to the equation of Z. If you go to the equation of Z, then you will be able to see. Okay, so sekejap ya. Saya pergi. Okay, if you see the equation of Z here, sekejap. Sorry, this is a lot. Okay, mana equation of Z? This is the equation of Z. Okay, so what you want to achieve now is to solve this part of the that part of the equation. Okay, that's why we are going through this hassle, or this hassle of calculating or drawing the lines. So what you want to get is the HYI, because you get HY from the calculation just now. But you can only get your HY1 from the correlation from the lines that you draw, right? So let's see. Do you want? Okay. So sekarang kita kat mana? Kita here, still here. Right. So sekarang ni, what you want to do is you want to practice what you have done in the first topic or in the first lecture that I teach you. Okay, so you want to find for this point, sekarang kita guna warna lain pula. Okay, this purple. Okay, for this point, okay, you want to get the HYI. Okay, and also for this point, you want to get the HYI. All right, so how do you get the HYI? Is first from obtaining this gradient. What is the gradient of that line? The gradient of that line is this: HLA over MBKGAP. Everyone should get the same number, which is 4.187 times 10 to the power of 4. Because these are all using constants. Okay, so everyone should get the same number. If you see the gradient is actually negative, so you know that the line should be inclined to the left. Okay, so for this particular point, which is the HY2 versus TL1, TL2, okay, TL2 HY2. Okay, you want to take macam you buat in the last class, just take any point. So here actually is 40 berapa tadi? 43 43?
43.
Point?
43.
43 sahaja. So this is for 43.2?
0.3.
0.3.
Okay. So this is 43.3. So this is 43.3. So the line slope is negative 4.187. So you should take a value not really far away from 43.3. So maybe you want to take a value like 42 or 41, okay, or 43, something like that. But I think the reasonable number should be 42. So when you take 42, okay, this would be your here. In this case, it's taking TL to be 42. Okay, in this case, you can choose whatever number you like. You can choose whatever number you like. So you can then determine what would your value of TL, not TL, the value of HY. Do you understand what I'm talking about? Kau tak faham
Doktor,
cakap?
saya nak tanya, kalau kita assume tu memang kena dekat dalam range operating line. How about kalau outside of operating line? Contoh macam saya ambil 28.
Okay, if you take 28, then your graph paper tak muat lah dia keluar daripada graph.
Tapi kita nak dapatkan dia punya cross section line je kan? Gradient dia.
Bukan. They actually like this. Okay, now if you take 42, what is the formula for slope? Slope mesti apa? Y2 minus Y1 over, macam tu kan? So your slope is Y2 minus Y1 over X2 minus X1. So this should be negative 4.187 tadilah, times 10 to the power of 4, right? So at Y2 dengan Y1, you already have the two, you don't have the two values yet. So what you have here is your Y2. Betul? So katakanlah your Y2 is here is 40, bukan 40, berapa Y2? HY2, sorry. HY2 is 128, kan? HY2 is 128. Take erase dulu ni. Kenapa dia tak pergi erase? Okay. HY2 is 128. Point berapa tadi? Tak ingat saya. Okay. 128 lah. And then HY1 is actually what you want to find. Okay. This one, X2, which is corresponding to that HY2 tadi is 43. Oh, sorry. 43.3. X1, you ambil one value, which is 42. Right? So when you put in 42 over there, 43.3 over there, and 128 point berapa tadi over here, what you can find is actually your Y1. So from this calculation, what you get is your Y1 would be 184 times 10 to the power of 3 as written in the slides. Okay. So kalau saya padam ni lah. You susah nanti nak tengok.
Doktor, S1 tu ikut je ke ambil yang berapa? Kalau tak ambil 42 tu ikut je.
Boleh. If you want to take 41 pun boleh. Nak ambil, tapi you have to be really clever because this is at the far right end of your graph paper. If you take a really far value from 43.3, takut pointnya dapat kat sini. So nanti, takut pointnya will fall here somewhere outside of the graph paper. So you don't want that to happen because what you want to do is you want to connect that point to that point. Nanti kalau dah keluar graph paper, you will be in trouble. Okay? So that's why I want you to take a reasonable value or not a value that's too far from your X2. Okay? So that's how you calculate the value. In this case, you get 184 kalau you buat dekat 42. So 184 something. So in this case, dia actually fall right on the equilibrium line. Okay, so let's say you take a value of 43, let's say. Okay, sini 43, right? So when you take 43 or 42.5 lah. Okay, saya katakan 42.5. When you calculate tadi tu, yang ni tadi tu, when you calculate that, what you get is actually a value somewhere here. Okay, so what you want to do is actually you take that value. Mana ruler tadi? So you take that value, you pun garis. Okay, you will draw the line there, and then you will extend to the top until you reach that equilibrium line. Okay, and then you will do the same for the point at the bottom here, which is TL1 and HY1. You do the same, take TL1 as berapa tadi? 29.3, and then you will have the value of HY1. Take a value of a temperature maybe 27, okay? Or sorry, 29. Take a value of 29, or you can take a value of 28. And then you will calculate what sort of Y value that you will get from there. Ini kan saya dah ajar in the first topic where you get you have one point and you have a gradient, and you can like guess or not guess. You take a number for the X value, and then you will calculate your corresponding Y value that falls for that particular X that you take, and then you extend lah. Kalau dia terlebih, you okay. But if it's below the equilibrium line, then you will have to extend. So, bukan saja tu, not only that, not only those two lines, okay, you have to do several lines along that. Banyak tak kerja? This is when involving film mass transfer coefficient. This is what you have to do in the exam.
Oh, yes.
Okay, so not only you have to do for this point and also for that point, you have to do maybe another 5 lines in between. Okay, so for each corresponding TL, okay, you want to get what is the corresponding HYI. Okay, remember the HYI value will always fall on the equilibrium line. Okay, will always fall in the equilibrium line. So what you get here from all the calculation is HYI corresponding to the TL. Ini, okay, the TL. Okay, so finally what you should get is okay, this is how it should look like. Okay, this is how it should look. It should look like there are in here 4 lines in between TL1 and TL2. So altogether you have 6 lines. 1, 2, 3, 4, 5, 6. Yes, 6 lines. Okay. So what I want you to do is to make a table. Okay. To make a table of all these values. This is your HY, apa ni? HY1, and this is your HYI. This is your HY, this is your HYI for that particular point. And then do that for all the points. Okay, semua kena baca for that HYI, and then you have to put them all in this table. Okay, because what you want to solve is actually the integral part of the equation here. So the integral part is 1 over HYI minus HY. Okay, so you write down your HYI that you get from the graph. If I were you, I will put HY on the left and HYI on the right, because HY is what you calculated before. Okay, you already have the numbers. HYI will come from your graph. Okay, HY belah kiri, HYI in the second column, and then you will take HYI minus HY, and then you will take 1 over this value. So you have to make this table on your own. do not follow this one, okay, on your own. Take the number from there, okay. So then you have to calculate the area under the curve, all right? So what I want to tell you now, you don't really have to plot the point of all this 1 over HYI minus HY. If you see this area under the graph, the y-axis should be 1 over HY minus HY, and the x-axis should be HY. Then only you can get the, kenapa di HY? Because the integral is actually from HY1 to HY2. So you want to find the area from HY1 to HY2 for your x values, all right? So what you want to find is the area under the graph. So you don't necessarily have to draw this graph. You can do it numerically, okay? How to do it numerically? You have to refer to chapter 9. I will look at it nanti, okay? And then, have you learned on how to calculate the area under the curve in numerical methods? Yes?
Simpson rule.
You still remember ke dah lupa langsung?
Trapezoidal
You don't
rule.
remember anymore? Sorry?
Simpson rule ke Dr.
Apa dia? Sorry, Aiman.
Simpson rule ke?
Simpson's rule boleh, trapezium rule boleh. So the easiest way actually is, nanti saya tengok dalam, saya tak bawa buku saya. So sekejap I will get out of this. So if you have your book with you, just carry on how to calculate the area under the curve, or carry on with the calculation of 1 over HY1 minus HY. I will show you on how to calculate this numerically, okay? I don't have my books with me. So let's see in chapter 9, I think somewhere there. So actually, I will show you the book, okay, on how to calculate the area under the curve without plotting the graph, okay. So if you see here, this is in your chapter 9. If you can see under example 9.71, actually this is what you're going to learn in unit operation and industrial processes next semester for drying, but the concept is the same. The integral that should be solved is 1 over r, okay, 1 over r in terms of dx. So the range is from x1 to x2. Can you see my cursor here? Ke tak nampak? Do you nampak? Okay. All right. So the equation is actually 1 over r. So you want to integrate it in x. Okay. So the x range is from x1 to x2. So the equation is 1 over r. So dia akan buat for the table, get the x, get the r, and get the 1 over r. Okay. So get the 1 over r. So you have here like 6 sets of 6 data. The number 1, 2, 3, 4, 5, 6 data. So if you want to find the area under the curve, oh, thank you very much. So if you want to find the area under the curve, you will have to take the value macam mana? Do you remember how you do it in numerical method? So first you ambil apa? Ini adalah equation dia. This is the equation. Okay. Sekejap saya tengok. This is not the one that I really want to show you. Bye-bye. Dia nak air mana? I don't know how. Sekejap Saya turun sini senang. So what you want to do is actually, dia senang aja sebenarnya. Dia guna the data saja. You don't have to plot the graph. You guna trapezium rule. You have to use trapezium rule. So let's see 10.51 here. So dia tak tunjuk kat sini what you have to do with this. Dia terus straight away show you the area under the curve is actually 1.82. Saya tak ingat page mana yang dia show you the trapezium rule. So dia sebenarnya ambil the average. Saya kena carilah equation tu. I will put the equation for the area under the curve later, okay, for this. So you don't really have to plot the graph, all right? So I will record something for you guys in after the class, okay, for you to calculate the area under the curve. So let's see again the slides. Or any of you still remember what you see in your numerical method, the trapezium rule? Who still remember? Chong, do you remember?
Is
Do you remember?
is like half 1 over
half.
2 hy1 minus hy2 bracket, and use bracket, and 1 over hy1 minus hy plus 1 over hy2 minus hy. I will send the photo. Yeah, I send the photo in the group.
So you use that trapezium rule, you don't even have to plot the graph, right?
Yeah.
Yes. So what I want you to do is you have to remember what you learned from the numerical method class. Okay. If you want to waste your time and draw this graph, you are very much welcome to do that. We will take that into account, but that will be like wasting your time. So what you want to do is just use this set of data and use the trapezium rule to solve it, okay? And then get the corresponding area under the curve. So once you get the area under the curve, you will put into this equation, okay? You will put this. Kenapa pula tak boleh erase? Oh, dia tak boleh erase dah. So you will put okay, so you put that area under the curve here, okay, in that part of the equation, and use the constant that you get there, which is all the constants on the left here, okay, and then put your area under the curve. What you should get in the end is your Z. That's all. All right. So and then, all right. So that's how you solve your Z. Anyone really have difficulties in this? Dah confused, dah lost, tak tahu apa dah?
Doctor, I have one question. Like for drawing a line from drawing the gradient from the equilibrium line to the operating line, right? after I get the one line, can I use the ruler? Use the ruler. Like
If
I
you're
use the ruler.
confident that you can get it parallel,
Yeah, I use the ruler to get it parallel. Is it okay?
you can. But I don't know whether your line is really parallel or not. You have to be confident in that. If you have a mechanism to make it really parallel to each other, ada dua ruler ke, and then you have that apa triangle ruler, kan ada that triangle geometry set. You can use that.
Kita guna sliding.
Sliding. You can if you want to save some time and you're in a hurry, you can.
Oh, okay. Thank you, doctor.
Any other question? Anybody now your understanding is less than 50%? Raise up your hand. Oh. Okay, now? All right. So you should be able to solve example 10.51. I want to see how you do it, and I will upload a link in e-learning for you to actually upload the example that you do. Okay, I don't want to go into this, which is the minimum airflow rate. This is like another set of different thing. So I will cover this maybe in a recording or in a live class on Sunday, if we have a live class, or otherwise I will post a recording on slide number 22, 23 and 24. Okay, so hari ni saya rasa you all dah penat dah. Ya, penat dah ke belum? Are you all tepu saturated already?
And ma'am, we just need to upload what we just write down here, like what we just exercise right now. Or just like we need to do it like clearly.
You have to do it properly with your own numbers.
Okay.
Okay, so do it properly. I will give some time for you, maybe until tomorrow, for you to upload your completed example. All right.
Okay.
Okay,
So I
Doctor.
think, all right. So I think that's all. Have a
When
nice
is our test
weekend.
one?
Sorry.
When is our test one?
When is it? When is test one? Test one. Let me see the timeline in our CI. Okay. That's actually in your CI.
Okay, then we will follow the CA time, right? Like what time is mentioned there?
Normally, it's before your semester break. Normally. So what's written in the CI? Which week is it? Oh, tak ada tulis. It's normally before your semester break. So maybe week 7, something like that, for your test one. So be ready. Make sure you understand what is covered online here. Okay. If you have questions, just ask me. Don't be shy. Okay, so I think that's all. If you don't have question, check ni ada siapa tulis lagi kat sini. Okay. All right. So if there's nothing else, I'll see you on Sunday. If there's live class, I'll inform. I'll let you know. If there's no live session, I will be posting a recording. All right.
Okay.
So bye. Bye everyone. I'll see you in the next class.
Thank you, Doctor.
Bye, Doctor. Thank you.
Thank you, Doctor.
Ya, satu. Siapa nak tanya dulu?
Yeah.
Siang.
Actually, I sent a photo like how I calculate the
Oh, you
area
sent to
under
me.
No, I sent into the group. Like actually, I using the trapezoidal rule, but I'm not sure it's correct or not lah. So I think Doctor can help me check first.
Okay, let me see. Yes, basically. That looks like it. But there's an easier way. I will show you how. There's a far easier way than this. Okay?
Okay, thank you, Doctor.
I'll show you in the next class.
Okay, and then
Okay.
is that we need to draw 6 lines compulsory? It's better.
Preferably.
Okay.
Don't draw just like 4 lines, or you have to look at the range of data you have from TL2 to TL1. If the scale is small, you have to make it bigger, and you have to be able to have a few lines in between. 4 is reasonable, 4 in between. So including the TL2 and TL1, you will have 6, something like that. Okay? The more the better actually, but you don't want to waste your time. Okay. Anything else?
Doctor.
Yes.
For the step number 6, why
Uh-huh.
you let TL equal to 42 degrees C?
You can choose any number you like now,
Oh.
In that example, the chosen value is 42. If you want to choose 41, you can choose 41.
Okay. Thank you, Doctor.
Okay? All right. Anything else? Dah. Ada dah. All right. So I see you next week. Okay. I'll inform of the manner of class that we'll have next week. Okay. Have a nice weekend, everyone.
Okay, thank you,
Bye.
Doctor.
Thank you.